This is exam 4, page 3, section 1, and this is problem number 3. And it states, suppose that the integral from 3 to 6 of f of x dx equals 7. We know that g of x is an odd function, and the integral from negative 3 to 6 g of x dx equals negative 4. We're finding this, and we're going to start with this statement. So since it's odd, this means that g of x is odd, I should say. It starts with the integral from negative 3 to 3 of g of x dx is going to equal 0. And then that means that the integral from negative 3 to 6 of g of x dx is what? So we're going to do, what we know is that negative 4, that equals negative 4, so we're going to do negative 4 is equal to the integral from negative 3 to 3 g of x, and then we're going to say plus the integral of 3 to 6 g of x is all going to be equal to negative 4. And we know that this is 0, so negative 4 is 0. So now we know that the integral from 3 to 6 g of x is going to equal negative 4. So you don't even need this because you know it equals 0. So once you have this information, you can start with here. You can remove the constants, put them both to the front, and you're going to do 2 integrals and separate. So it's going to be 3 integral 3 to 6 of f of x, and then we're going to do dx, and then minus, again, the constants taken out, integral, and it's going to be from, again, 3 to 6 g of x d of x. And what we know is that we're given that the integral from 36 f of x dx is 7. So we could do 3, because that's the constant, times 7. And then minus, it'll be 1/2. And then what we calculated was that this integral here of g of x is negative 4. So we'll do 1/2 times negative 4. And then that means we'll get 21. And then it'll be plus 2, because and then 21 plus 2 is 23. And that's your final answer.